In these times of social distancing, you have to know how far away is one person from the other. Therefore, distance formula. Distance formula using the Pythagorean theorem in a coordinate plane. Let's start with this. A school is at A, 3, 2, and the city hall is at B, 9, 10. What is the distance between the school and the city hall? First of all, we need to plot the points. Let's start with this point and that point. This is A, 3, 2. That will be the school. And then 9, 10. This will be the city hall. Okay, we want to know the distance between them. But it's a diagonal. It's not a horizontal. It's not a vertical line. So you cannot just count the number of units. But guess what? You can use Pythagorean theorem to solve this. Okay, so that's the distance that I need to know. This one I can count. This one I can count. Obviously, that's the base. And that's the altitude. Guess what? It forms a 90-degree angle, so I could use it using Pythagorean theorem. Okay, in the Pythagorean theorem, we learned that the hypotenuse squared is equal to the square of the legs added together. So, let's plug it in. So, if the distance here is 10, and the distance here is 2, what is this distance in green? So that's a 10 minus the 2, we have 8. How about the distance in blue? Okay, the distance here reaches up to 9, the distance here reaches up to 3. So we subtract the 3 and the 9, we have an 8 and a 6. But you know, if it's a graph, you can already count it. Is it really 8? 1, 2, 3, 4, 5, 6, 7, 8. There you go. How about, is it really 6? Yes, you can count it. 1, 2, 3, 4, 5, 6. So you put 6 over there. So remember Pythagorean theorem? So the 8 and the 6. Now, we want to know that. Therefore, 8 times 8, 64. 6 times 6 is 36. Let's add them up. That's 100. And to undo a square, we square it on the left, square it on the right. That cancels out. Therefore, C is equal to 10. This diagonal, this hypotenuse, so line AB has a distance of 10 units. Now, let's try another one. But before we do that, do it on your own. Pause. Ready for the answers? Here we go. Point -3, -5 is over here. Another point 9, 1. 9 and 1, that's letter D. We connect them. We don't know the length of that. But we could identify this, we could identify that. Okay? So this will be my B, my base, my A, my altitude. C is the hypotenuse which we want to solve for. Okay, we use the Pythagorean theorem again. So I subtract 1 minus the -5 and then 9 minus the -3. There you go. So, but remember your rule in subtracting with signs. Keep change opposite. That becomes 1 plus 5, 9 plus +3. So, I can add now 6. This becomes a 12. Square here and a square there. That's going to be 36 plus 144. You can use your calculator, of course. Add them up, you will get 180. Square it on the left, square it on the right, use your calculator, you will get 13.4. So, CD is about 13.4 units. Using those examples, let's derive a formula. So, a while ago we said if C is x1, y1, and D is x2, y2, we want to solve this distance. Okay? We have the vertical distance and the horizontal distance, which serves as the legs of the hypotenuse. So you're the B and you're the A. And the distance is the hypotenuse. If we follow the Pythagorean theorem, that distance A How did we get the distance from A? By subtracting y2 minus y1. And that's the length. See that distance? Minus this distance is that distance. So we subtract y2 minus y1 and then x2 minus x1. And then since we're solving for the hypotenuse alone without the square, I square root on the left and a square root on the right. This cancelled out, therefore C is equal to that formula but with a square root sign. So this is our distance formula. This is now called the distance formula. This is used when you have 2 points on a plane. Now, did you see the similarity between the slope formula and the distance formula? Remember doing this before? Remember doing that before? How come you need to subtract the y coordinates? Because those y coordinates are the rise. Alright? And then when you subtract the x2 minus x1, this will be the run. The rise, the run. And this 2 also represents the legs of your right triangle. So, the rise and the run are the legs. We solve for the distance between them, and that is the hypotenuse. Okay, we have some problems here. Pause it. Try to solve it. So here are the answers. y2 minus y1. So that's going to be 2 minus negative 3. Okay, those are the y's. Negative 6 minus negative 2. These are the x's. Be sure you use the correct numbers. Okay? So, keep change opposite. Keep change opposite. That becomes 2 plus 3. This becomes negative 6 plus 2. So, this 2 I could add. That becomes a 5. This 2 I could add. That becomes negative 4. Okay? Square it. Square it. It's going to be 25 plus 16. And I get square root of 41. The calculator answer would be very long, but it says here round to the nearest hundredths, and hundredths is over here. Will the 3 affect the 0? No. Therefore, when I round it, it's going to be 6.4. Next problem. Pause. Okay, ready for the answers? Here we go. Negative 2 came from here. 9 came from there. They are the y coordinates. This one is a negative 12, and that came from there. Subtract them, but remember, keep change opposite. So that becomes negative 2 plus 9, negative 12 plus 7. We could add these 2, that becomes a 9. Add these 2, that becomes a negative 5. Square them, 49 plus 25, and then you'll get 74. And next, to get the square root 4 is a non-terminating decimal, but it says here, round to the nearest thousands. And where is thousands? Thousands is over here. Will the 2 affect the 3? No. So it stays the same, 8.602. Next, pause. All right, ready? This one's easier because you don't need to use the formula. You can easily see, you can easily eyeball what the legs are. I could see the vertical distance of 3. I could see a vertical distance of 1, 2, 3, 4. So you got a 3 and 4. Actually, you already know the 3, 4, 5 is the basic right triangle. But anyway, let's just show work. So square root of 3 squared plus 4 squared, that becomes 9 plus 16. Square root of 25 is 5. 3, 4, 5. The basic right triangle. Another challenge. Pause. Take note, this is not just one unit. 2 squares makes 1 unit. Alright, so from here, I could count 1, 2 units. So I put a 2. From here, I could count 1, 2, 3, 4, 5, 6. 6 units, so I put 6 over there. Those are the sides of your legs. Therefore, it's easier to solve now for the hypotenuse. So plug it in. 2 times 2 is 4. 6 times 6 is 36. Add them up. Square root of 40. It says nearest tens. Tens is over here. The 2 won't affect the 3. Therefore, the answer is 6.3.